Okay, right. So let's look what we will be looking into and which things we will cover during the first day of Qt for MCUs training. So this one. So as the first thing, we will go through the Qt for MCUs package content. So we will learn what's inside what's inside the package that comes with Qt for MCUs installation. So once you select that in Qt installer, what is really installed on your device. Then we'll see how to build and run your app from the command line. So the most raw and most basic case when you would like to create your application project for Qt for MCUs and then compile that directly from the command line. So this point is exactly about this. This will involve some CMake APIs, so we'll also cover more of them. We'll look what are the responsibilities in Qt for MCUs. If it goes about the CMake, we'll go through Qt for MCUs application build process. It's a quite complex thing, so it's good to understand how the particular tools are doing that process, where the compilation is, and how the assets are working. This will be in that point. After those points, we'll have a short coffee break. So after getting some rest, we'll get back to see how to configure your Qt Creator installation to work with Qt for MCUs and compile your apps for particular devices. And we'll follow that with a live coding session in Qt Creator. I will show you how to create your basic project, how to compile your first application using Qt Creator. And after that, we'll go for a bigger break. So we'll go to eat something during the lunch break. And after eating, we are going to see how to include some assets to your application, some images that could be displayed in your application dynamically. And we'll of course follow that with a live coding session that will show more in detail how to manage your application assets. And quickly about the second day of our training. So tomorrow we'll see what is different between Qt for MCUs and Big Qt. We'll cover the topic about styling the controls, so any custom buttons, sliders, and so on. Styles will be also explained. The short coffee break will go there, and after that we will learn how to translate your app, so how to provide different languages for it. There is another lunch break, and finally quite a big topic about C++ integration to understand how connect your C++ parts of your app together with the QML code that defines your UI. Pretty interesting thing, and I hope you will learn something interesting. So getting started and directly from the software requirements. Microsoft Windows 10 is the only supported operating system right now. So if you would like to go through all live coding sessions, you have to work with Windows 10. Linux will be supported shortly in the 1.9 release. It's coming in the, I don't remember exactly, but it will be really shortly. macOS support is planned, of course, but we don't know when it will be. But if you are curious, if you are going to support macOS, we will, but we don't know when exactly. Of course, Qt for MCUs 1.8 is needed, and you can, of course, download that directly from the Qt installer. And well, maybe let me show you more in detail if it goes about Qt Creator and Qt for MCUs things, as you can install that directly from the Qt installer. So let me just open Qt installer. Well, here it is. So after running that. You have the login screen, so please just type your credentials there and click next. It will take a while to gather all the informations. Then we will select add or remove components. Click next. It will still take a while to download all the metadata there. All right, here we go. So just make sure that you have selected latest releases. So this checkbox has to be green. You can close the preview section. Additional libraries are not needed. Let's go to Qt. You don't have to install the big Qt. I have installed that for different purposes, but this is not needed. You just have to go to developer and designer tools. Let's expand that one. And of course, you need Qt Creator, you need CMake, and you need Ninja, which will be needed later on. And if it goes about Qt for MCUs, for sure you will need a desktop backend, which will be needed to test our application on the desktop, to not flash every time you made any change your app to the device. This will save a lot of time for you to test some of the UI changes directly on the desktop machine. And during this training, I will be using NXP board RT1050 evaluation kit. So if you're going to use that one, then just select the checkbox near the NXP IMX RT1050 EVK. And that should be enough for Qt for MCUs 1.8.0. And from the third-party tools, we will need ARMGCC8. This is the compiler toolchain for to compile the application for your target board. Oh, let me close this pop-up. And then there is NXP 1050 SDK, which is also the required thing. You can install that one directly from the installer. And we will need NXP MCU Expresso IDE to provide tools to flash your device from the host machine directly from Qt Creator. And if it goes about Qt installation, that's it. So normally you just click next. I will click close as I have all of those things installed before. Do I want? Yes. Okay. So as I said, this covers Qt for MCUs 1.8 installation for desktop and the board. Qt Creator is also included in that installation, and the CMake is selected from tools. There are also the Ninja. There's also a Ninja tool that I mentioned will be needed later on. And of course, for the Windows 10 and for the desktop backend, so to test your app on the host machine, you will need MSVC compiler that comes with Visual Studio installation. So let me open Visual Studio installer for it to show you what is exactly needed. Let's continue. Let it do something to start. If you have any questions during this training, just please use the Q&A section. I will try to answer all of those as soon as it's possible. It's a quite slow installer, so let's give it a bit more time. Okay, something is happening, but I'm still not able to see any installer. Oh, well, could I paste the link for MSVC here? I will try to find that out. Let me copy that. It should be there. Hopefully, you will find out the installer and online installer here. But, I'm curious why it's not showing up for me. It's still processing something. Maybe let's use that moment once the Visual Studio installer is setting up. Okay, here we go. How to cancel? Okay, here it is. So once you have the installer ready, you will have to select one of the things. So Visual Studio Express 2017, you can choose, of course, some other installation, but depends on your selected the general package. You just have to click Modify, and you just need two things from there. Go to the individual components, and let's search for the compiler first, MSVC, and the required version is V142. So just let's select that one. And the second thing that is needed, it's Windows 10 SDK. So just let's type Windows 10, and then there is Windows 10 SDK that you just have to select. Okay, and there are some more questions. No, right now there is no free license for Qt for MCUs. You can contact us, but I see Jakub, who is my friend that is helping us today, is just right now typing the answer for you. But generally, no, it's not available. Let's wait for the answer from Jakub. And in the chat, okay, there is another link. Okay. So as I said, those are two things that are needed from Visual Studio installation. So basically, the MSVC compiler and the Windows 10 SDK that you have to install together with your Visual Studio installation. Those both things are needed by our Qt for MCUs desktop backend to compile your application for the host machine. Okay, one more thing. The documentation for Qt for MCUs is available online, and I can show you where. So here it is, doc.qt.io/Qt for MCUs. And here you can find documentation for 1.8, so for the most recent version right now. You can find all documentation for more detailed things like platform implementation details. You can find the general things that are common for whole Qt for MCUs, some manuals, some tutorials, how to set up things. It's all online. Okay. Before we go further, I will share the link with you so you can prepare yourself for live coding sessions. Here we have a link to materials that I will be using during the training. You have right now a moment to download those before I will start coding anything. Okay, let's get back to presentation. This one, okay, this one. Okay, so this is about the setup of the environment and all of the things that are needed. And let's focus on package contents. So what comes with Qt for MCUs installation? For sure, you are receiving the quick ultralight graphics runtime, so the heart of the whole Qt for MCUs. So this is the engine that computes all the computes position of all of the controls that you are placing on the screen. This computes the refresh regions for your application. It controls the lifetime of it. And generally, it's common for all of the Qt4MCUs ports for particular boards. Also, you will receive Qt Quick controls, which is a subset of Qt Quick controls that you can know from the big Qt. And also, you will receive default styles for it. And there's a platform adaptation for the platforms that you have selected during the installation. Previously, I was showing you to how to install that platform adaptation for NXP 1050, and this is exactly about those platform things. Development tools are also coming together with Qt4MCUs installation. You will receive the Qt Creator and all of the stuff that is needed to integrate it with Qt4MCUs. And of course, you will receive the Qt Linguist tool to provide localization support for your application. Offline documentation is included as well, and examples with source code are also delivered together with the installation. And the folder structure. This is something that I will show you directly on the file system. Well, here we go. This is the Qt installation directory, the root one. So just the C and Qt. And let me briefly go through the things that are there. So maybe as the first thing, let's focus on the tools directory. This is the place where all of the tools that you're installing through the Qt installer are going into. And for example, we have a CMake there. We have a Ninja that we have installed before. And for example, there is also a Qt Creator tool, which is quite a big one, but still it's a tool. And this directory Qt MCUs contains only the stuff that is specific to Qt4MCUs. And as you can see, here is the ARMGCC toolchain installed and some NXP related stuff like the SDK for the 1050 board. And also there is an installer package for MCU Expresso IDE. Okay, let's get back to the root directory and let's see what's inside Qt4MCUs installation. And in the root Qt installation directory, you can find Qt MCUs. Then there is a version of it. And here it is, the root directory of Qt4MCUs. And let's go through all of the directories that are here. In the bin directory, there are located some tools that are needed during the compilation process, like tools for converting the images, tools for generating the C++ code from the QML, and so on. And as you can see, there is also a bunch of DLL files which are needed for Qt backend, for Qt4MCUs desktop backend, and by having those files, you don't have to install the big Qt, the whole big installation. You just have to point those files. We'll cover that later on. There is also a compatibility module, which provides some compatibility types and plugins for Qt tools to cover the types that are specific to Qt4MCUs and to still be able to use the types that are specific to the Qt4 microcontrollers. Demo images contains precompiled binaries for both bare metal and the FreeRTOS. Contains precompiled demos for all of the boards you have installed. In my case, it's quite a big set. Probably if you have selected only one board, it will be a few of them. And as you can see, these are compiled with different compilers and for different demos. The same goes for the operating system. Demos contains the sources for those precompiled images that I was showing before. Docs contains offline documentation examples, of course, contains sources for small apps that are showing some particular features. So if you are going to search for how some features are working, probably you will find the answer here. Include directory contains the general headers and the things that are needed during the compilation process. Of course, the kits are for Kit Creator to find out the configuration for particular boards, how to connect the compilers, the tools for flashing, and so on in the Kit Creator. A tool. Lib directory, of course, contains all of the precompiled libraries with for the boards that you have installed. These are libraries for quick ultralight, for the platforms, for styles, and so on. Platform contains platform-specific parts of Kit for MCUs. So, for example, for the NXP boards, STM boards, and so on. Plugins, of course, plugins for Qt tools like Qt Creator. And the source contains additional files that can be used in your projects to speed up the things. Most of them are common things that are prepared, and those are mostly the most basic implementations for example, some main entry points for apps, some code initialization, and so on. Okay, so this is about the installation of Qt and how it looks on your machine. And let's get back to presentation. I mentioned before about desktop backend, and this is a quite powerful thing. Even if it seems to be a basic thing, it really speeds up the development of your application for microcontrollers, as you can still run your app directly on the machine that is used to develop the product. You're saving a lot of time for checking small changes on your UI. You don't have to flash your device each time you are making a change. Okay, there's another question. Can we use Qt open source for MCU? Well, as I said before, the Qt installation is not needed for Qt for MCUs, and Qt for MCUs is not available for free. So basically, you cannot. This is the correct answer, but well, if you have the license for Qt for MCUs, you don't have to use Qt, let's say. So you don't have to have the license for both. Okay, let's get back, as I missed something probably. This is another point as well, that required Qt libraries are shipped together with Qt for MCUs. So, as I said, if you have the license for Qt for MCUs, you don't have to have additional one for big Qt. And desktop backend on the Windows 10, of course, is compiled with MSVC compiler, which is, of course, needed there. There is a plan to switch that to MinWG, but this is the future, and right now we don't know when exactly this will happen. And yeah, this is about the desktop backend. And here we are approaching the first live coding session, but before there is another question. Well, okay, right. So maybe let's get back for a bit between the, and I will answer the question. So the question is, what is the main difference between Qt for MCUs and Qt? And what are the advantages? So, well, Qt for MCUs is a completely new product. So this is the whole framework is written directly from scratch. It uses some parts of the big Qt, but in general, this is a completely new product. This is a lightweight version, really lightweight version that can be run on the microcontrollers that are really I would say thin and have no such a big power, and for sure you cannot run the Qt on the, for example, Cortex M4 with 1 megabyte of the flash and half megabyte of RAM, and you can do that with Qt for MCUs. And this is the biggest advantage of Qt for MCUs, that it comes with really lightweight support for the microcontrollers that are really cheap and does not have a lot of well, I cannot find a word for it, but typically the targets for Qt for MCUs are the boards with low resources. You don't have a lot of memory, you don't have a powerful GPU. Typically, you don't have the GPU as well, and all of those things are working fine together with Qt for MCUs just because it consumes a way less memory, a way less resources if it goes about the CPU load, and if there is any GPU load. And this is the biggest advantage, that Qt for MCUs is a completely different product, and it's a completely lightweight one. Probably we'll cover some more parts of the differences later on during this training. Okay, so let's get back to the live coding session, the first one for us, and what we will learn during this live coding session. So we'll learn how to set up the CMake project from scratch. We'll build your application using the command line, and we'll of course run that up. Okay, so let me set up the things there, and okay. I will open the terminal window. I have prepared the training directory for our training meeting, and I will do all of those things just inside this directory. And I will start from creating a special directory for our new application. I will call it first up. And let's go inside that one. Okay. As you can see, it's empty. And right now I will open Visual Studio Code. You can choose any editor as you wish. It's not that important. Just have something to write. And I will create a file, main.qml. Here it is. So we have our new file, which is still empty. And the first thing we will need there is some import. Qt 15. In Qt for MCUs, the version of the import is not that important. It's just a good practice to put that there as Qt creator requires from us. The version, and it will show the error in the IDE once the version is not there. But as I said, it's just a good practice for Qt for MCUs to still put that version there. But it's completely omitted and it's optional for Qt for MCUs. And our app will be just a simple rectangle with a color magenta, and save the file. All right. And it should be it if it goes about definition of our user interface for now. It's quite a simple thing. And let's get to creating a CMake project. So once again, I will create a file using the Visual Studio Code, and it will be called CMake lists.txt. Okay. This is another empty file that we'll be filling. And the first thing in CMake is to define the minimum version that is needed. CMake minimum required. And it's version 3.15. Okay. Then we have to define the project for our app. It's first up. Okay, okay. And languages are also needed there. And we will use C++. We have to find the package. We'll provide additional CMake stuff for our application that comes from Qt4MCUs. And Qt4MCUs package in CMake APIs is called tool. Okay. And briefly, we have the project set up, but still we need to add the target. And to do so, we have to use one of the Qt4MCU specific macros. And this is the qul_add target. Okay. And the additional thing is to connect our QML file with our project. And to do so, there is another CMake macro, qul target QML sources. First up, and it's main.qml. All right, and the one missing thing for now is to have some entry point. And by entry point, I mean your application will have to define the main function. And Qt4MCUs comes with default implementation for those. And you can simply use one of the macros to use that default main entry point by default. And we will do that right now. It's up target default entry point. And that entry point goes for the first app. And we are going to provide the main root QML file, which is of course the same name. So just a name without the extension there. Okay, and right now there is a good moment to mention that some of the macros from Qt4MCUs package are starting with qul_, and some of them are starting with up_. And it's not a mistake and not any inconsistency. It's by design. So the qul_ macros are the essential ones and the ones that you are probably going to use in every application. And those are the mandatory things that are the part of Qt4MCUs APIs. And those with the up_, are something optional. So you can completely omit that part and you can define your C++ file with a definition of your main function, and then you can define all of the setup there, and you can run Qt4MCUs application directly from your custom file. And well, so basically qul_ also this is something needed, and up_, this is something optional. Okay, let's save the file and let's try to build that up. Maybe as the first thing, let's review what's inside the directory. And not a surprise, we have those two files that we have created. And right now, we'll have to define some environment variables to set up the environment for us. So for sure, we'll need to know where the Qt4MCUs installation is. And to do that, I will define the qul_dir environment variable, and I will point that to Qt4MCUs installation. So let's see, Qt MCUs and 1.8, and that's enough. Okay, and we will need the CMake, as right now I don't have any in my path. Yeah, I don't have. So let's set the path to, just please keep in mind to preserve the previous path content. So set path to path and then semicolon and directory of our CMake tool, and it's also under Qt tools, CMake, and the bin directory. Okay, let's verify if that works. CMake CMake version, and it works right now. Okay, and I think right now we can try to compile our app, and as it's always in CMake, we have to create another directory for build desktop. Let's go inside and let's trigger a CMake. Let's generate the targets for the parent directory. So for a directory that contains our CMake list.txt and the QML file. And then let's define some CMake variables. It will be a QL specific one. So we are building that for the desktop backend. So we have to provide the QL platform, which for the backend is just Qt. Okay, and it's for the architecture x64. Okay. CMake is now generating the targets for our app, and it successfully did that. So we can try to build our application. And to do so, we are just typing CMake, and let's build this directory with a target first up, and let's configure that to release. And well, here we go. A compilation process has successfully passed, so we can try to run our application. Release, and our app will be just the first app.exe. And what happened? The error happened, and that's normal. And as I previously said, Qt libraries that are needed to run Qt for MCUs application on the desktop are coming together with Qt for MCUs installation. So normally we just have to provide the path to tell the operating system where those libraries are. So let's close the error message and let's provide the path for those. So once more, let's extend the path by preserving the previous path, and we have to point qldir and then by bin directory. Okay, and we can try once more, and perfectly we have our Magenta application running. So this is the Qt for MCUs application running with Qt with the desktop backend. And as you can see, you can run such application directly on the device that you are using to develop the app. And you can wonder how to do the same for your device. And we will cover that right now. Let's get back to the root directory of our application, and let's create another directory for NXP board. Build_NXP, and let's go inside. All right, and well, we'll need some more environment variables right now, and to do that, let's set the first one for the compiler toolchain. It's arm gcc _dir, and it's also located under Qt installation directory. So let's go to C, Qt, tools, Qt MCUs, arm gcc 8. Okay. Some environment setup is also needed for the board itself. So we have to tell the Qt for MCUs where we have the SDK for the particular board, and to do that, I'm defining another environment variable that is specific to Qt for MCUs, evk b_imx rt 10 1050 underscore SDK path. And we have to point to Qt installation directory once again. C Qt tools, Qt MCUs, NXP, and there is the SDK that we have installed in the Qt installer. Okay, let's set that. And also there is, if you are going to flash your device directly from the command line, you have to tell where the tools from NXP that does that are located, and we will define another environment variable, MCU express IDE underscore path, and it's under C Qt. Oh, sorry, it goes to default C NXP installation. It's a separate tool that it's not from Qt, so it's installed outside. MCU Express IDE, I have 3 versions of those, so I will choose the most recent one. And let's set that. Okay, and the last thing to cover in the environment setup is to extend the path once again with the path to Ninja. It will be needed to generate the CMake targets in a different way than for desktop. So once again, path was extended with C Qt tools Ninja. Okay, and let's verify Ninja. Ninja version, it is. Okay, perfect. Okay, and right now we can generate the targets for our application in the CMake. So CMake double dots, so for the parent directory, and let's pass some variables to the platform, and it will be different. So okay, RT 1050 EVK. And let's see, let's notice that we have the name of the board. So MIMXRT 1050 EVK bare metal. So we are providing also the operating system or no operating system in the Qt platform. And then the build type for the CMake. So the CMake build type, and let's pick debug this time. Okay, and we have to tell that we will be using different compiler for the board, of course. So the CMake toolchain file, and this will be quite long, but hopefully we'll get out from that. Okay, killdeer, and let's focus right now. So it's coming from killdeer environment variable, then in lib, then CMake, kill, toolchain, and arm gcc.cmake. CMake, okay. And last thing, to pass the generator Ninja. Okay, and hopefully it will work. Let's hit enter and okay, perfectly. Here we go, and we have generated targets for our NXP 1050. And let's try to build our application. And to do so, we are just right now using Ninja, so it's easier. Just let's type Ninja and first up. As you can see, the building process is ongoing, and okay. So the build process has successfully finished, and let's try right now to transfer our application to the board. But before that, there is okay, there is a message from my friend. So okay. So just let's continue. Okay, so right now I will just show you what I will type in the command line. I will type ninja flash first up, and those flash underscore and then a target name targets are the things that are coming together with Qt for MCUs, and those are prepared to automatically flash your device if it's connected. It's using some tools that are coming from the vendors of the boards, from various vendors for various boards. In our case, it's using the RedLink toolchain from the NXP. From the NXP IDE installation, and I will just hit enter in a while. But right now I'm switching the view to additional camera to show you what will happen on device. So right now you should be able to see the board that does displays the hello world, and I'm hitting the enter right now, and it should flash our board with new content, new application that will be hopefully our magenta one. And here it is. You have to trust me that it's magenta, but it really is. And just the quality of the camera is not good enough to display the exact color of it. And okay, let's, in this case, get back to sharing the screen. All right, here's the output from the flashing. And this is how it basically looks like. If it goes about building and transferring your app and running it across the devices or the host, using just the command line tools and just the environment that is set up directly in the command line. Okay, so we covered all the things from those 3 points. So let's go further. And this is the summary of the things we just did. So to configure your project, you have to create some specific application directory. You have to, of course, create the files and so on. You have to provide environment setup. So you have to define the QDIR directory that will point to your Qt for MCUs installation one. You have to create separate build directory for your CMake targets and all of the CMake generated things. And of course, you have to provide some CMake variables to define the platform, to pass different toolchain files that will switch your compiler. And well, to build that, you can use the default CMake syntax, and that can be a long one. And of course, you can use the Ninja generator, for example, that will short up the things. And I think that's it. And just keep in mind, and just remember to extend the path with the Q installation directory and /bin to have the visibility on the libraries that comes together with Qt for MCUs installation to run your application on the host machine. And as you probably saw before, I was using some of the CMake APIs to control. Okay, there is a question. Could you show the flash command, and would this have to be set up for new boards using the board tools? I'm not sure I completely understand the question. I can show you the flash command. Okay, here it is. So for the boards, you have automatically generated flash targets. So you don't have to type your whole flashing command using the tools that are usually hard to just type in your terminal. But in the Qt for MCUs generated targets, you have that one. So you can just use flash underscore first up, and that will cover the flashing commands underneath. It will use the tools and the configurations that are already prepared for you. And basically, except defining some environment variables to tell your system and Qt for MCUs where those tools from NXP are lying, or for the compiler or so on, there is nothing more you have to do. It will automatically generate it if only you will provide those variables I was showing you before during the environment setup. So basically, well, this is the command that you would like to run, ninja, then flash underscore first up. And this is the only thing you will have to run to finally flash your device. And of course, here you can find the whole output from it after the flashing is done. So basically, ninja, once again, flash underscore first up. Hopefully it will answer your question, but nothing specific besides setting the environment variables is needed to have those flash targets. Okay, I answered. Okay. Perfectly. Okay, so let's get back to the CMake APIs. And as you saw before, I was using few of them to control how Qt for MCUs compiles and how Qt for MCUs connects QML files together with the application target and how to define some default entry points. And right now in this section, this part of the training, I will cover some more of them, and I will tell you what are. Oh my God, my mouse is switching the slides for me. Sorry about that. So let's focus on those, and let's start from the Qt platform. We were using that in the first live coding session. This parameter, this CMake argument variable, is telling Qt for MCUs which platform you are going to use right now when generating the targets. So Qt is a default one, and as well it's a target and the platform for desktop backend. And it means simply that by compiling for this platform, you will be able to run your app directly on the device that you are using for developing. All other platforms are defining the real hardware, that is the MCU hardware. And as you can see, this could be a STM board, this can be a NXP board, in our case, the second one, the 1050 VK bare metal. Of course, it can be the FreeRTOS to switch the operating system. The Renaissance boards are supported, and so on, so on. And this is to define which board you will be using. QL color depth is defining, in fact, the default color depth for your frame buffer. On the boards that are using the only single frame buffer, it's generally the default and the target color depth for the frame buffer. So it must be one of the 8, 16, 24, or 32 bits. It will define the color depth, and by lowering the value, you will of course lower the amount of memory that is used for your frame buffer. And going higher, of course, you will bump up the memory consumption for the frame buffer. And of course, it will increase the time that is needed to draw your things on that buffer, as it will require more pixels to be drawn. But as I said, this is the default and the target one for the boards that are using the single frame buffer. But there are also the boards that have a concept of layers. I can cover that later on during the on the end of the training, but those are using multiple color depths, and this will be the default one then. To create the application target, we have our Qt for MCU specific QL@target macro, which takes the name of your target. It can also take the additional argument that is different from the @target that comes by default from CMake. And that means if you are using the static library argument, it means you are going to compile your application, your Qt for MCUs application, as a static library. And then you can link that library to your final application, your final binary somewhere else. And this is pretty useful if you are going to create some bigger product and it will allow you to create some such static library instead of the final binary that is prepared to be flashed on the board. Of course, there is also a list of the sources that could be added to your application, and there is below that there is an example. So for the example app, you're providing some sources, source 1 and 2. To add the QML files to your project and connect that to with your target, we were also using that one, target QML sources for the target, and there is a list of the QML files. Of course, there is also a bunch of handy arguments, additional arguments, like the output directory, which will redirect your artifacts from the compilation process to some specific directory. There is also a module URI, which is currently the deprecated API since the version 1.3. It's the old way of creating modules for your QML files and QML structure. And there's also a copy QML files optional argument, which tells that the source QML files that were used to create artifacts are also copied together to output directory. This could be pretty useful when you are going to reference those QML files later on during compilation process. If it goes about application entry point, let me just take a bit of water. It's really a lot of talking for me today. So to define default application entry point, you can use the set of the app underscore functions and or the macros. And first of those is the app target default entry point, and this is tying up the target, so your application, together with the root item, so with the root QML file that will be a start of your application UI. And well, it provides the default implementation for the main function, for initialization of the board, and the QL itself. It will run the exec function, which is the permanent loop that that takes care about your whole application lifetime and whole rendering loop inside. And of course, this function template depends on the OS and the target type. So this directly goes to the another macro that is a second one on this slide. So it will behave differently and will take the different default entry point if you are going to use, for example, operating system. As operating system itself needs some initialization as well, then those default entry points will differ a bit. But still, Qt Frame's use will be initialized almost the same. To create a QML module, there is a new API. Previously, I said that there is some deprecated property in one of the macros, and this is the new way of doing that. So here we are providing the target, of course, and the URI that you will be using further to reference your module in other QML files. Of course, list of QML files is going there, some headers if any are needed, some sources as well, some imports that are used across your module, and of course, output directory that can be used to define where your artifacts should be located after the compilation process. And this is also the way, and that is the only way, and that the required thing to create the QML singletons. So if you are going to create a QML module, the QML object, some type that you would like to reference across all of the QML files globally, you are going to create a singleton, which can be created only by calling this macro. There are also some other commands for adding the resources. There is a QL add resource. And this one is pretty simple. So you're just providing the target and the files for it, some PNG, JPEG, and so on files. You can define the prefix. We'll explain that later on. Base, this is to shorten or extend the path that you're using to reference your files in the QML then. And of course, the output directory to redirect your artifacts. For translations, there is a macro that will embed your translation files in binary form in your final binary of your application. And to integrate your C++ code, there is a QL target generate interfaces macro that takes header files that are converted to QML interfaces during the compilation process, completely seamless for you. Well, this is for the second day of the training. We will also be using that later on. Some properties related to fonts, QL font 0, will define where your fonts are located. By default, it's located in one of the subdirectories of Qt4MCUs installation path. As you can see, it's in the installation path /source third-party fonts, and the default fonts are lying there. And by switching that property, you can show Qt4MCUs build structure where additional fonts that you will reference further are located. And this which fonts you are using can be switched by QL default font family and by other ways as well, but QL default font family is to set that globally. So you can just define a default font for the whole app without switching the font.family property for text and the static text components in each place. Some properties, variables related to QL texture cache, to resources. So this is the QL texture cache, and this is the super important one, and it's related to cache mechanism, and this defines the maximum size of the image cache, so the maximum size of bytes that your image cache can handle. And the first most important thing regarding this variable is that it has to be defined before calling add executable in the CMake. Otherwise, it won't work. And well, it's required if you are using image compression and or if you are going to copy your files from the flash to RAM. But basically, it will mean that if you are going to use compressed images, those will be decompressed in the runtime, and that decompressed data have to go somewhere. And the image cache is the place where those decompressed data is going. And well, it has to be big enough to fit at least the biggest image after decompression. And the formula you are seeing on the screen right now is to compute the minimum and at least the size of the image cache that has to be set to work properly. Because if you will set this to too low value, it will not, the biggest image will not fit in the memory, and your application will simply stop working. And from the other side, if you will set this value to big one, you can overlap other parts of your code in the memory or your application, and this can lead to, in the best scenario, bad performance, and in the worst scenario, some malfunction or undefined behavior. So this variable is really important one, but it should be used with special care. Some additional things, you can enable generating JavaScript bytecode by defining QL debug bytecode. This will be then generated as a comment to the right side of the code from the artifacts of the build process. Ql debug line directives is enabling generating the line directives that will point back to your QML source, as all QML sources are converted to the C++ during the compilation process, and then that C++ code will have the line directives, which will point back to QML source and will tell your debugger where to place your step instruction, let's say. So you will then know which line of the QML source was responsible for particular situation in the code, some auto-generated code. Okay. This was a lot of the CMake stuff, so let's right now switch to other topic, which is the Qt for MCUs build process. And that one is a quite complex thing, but we'll go through all of these steps to understand how your files are processed, how artifacts are processed, and when all of those things are combined together, and why all of those works. The first thing is to define of course, your project in the CMake list.txt file. This will tell Qt for MCUs how to process and which file to process at all. So this is the complete start to have the CMake list.txt file, and depends on what's there. We are going through these steps, and let's focus on the left side on the images. So the first thing is to compile the resources. So all of the PNG files that you added to your application are going through the tool that is called curl_rcc, and this tool is converting all of those images to the formats that are known and needed by Qt for MCUs, and those will be C++ files at the end after the curl_rcc will finish its job. And those C++ files will contain the bitmaps in the normal CRIs of the given format. For example, ARGB32 or Alpha 8 or so on. If you are going to use the compressed format, curl_rcc will compress it again and will put the image in the format that is known for Qt for MCUs. Then there is a time to compile the fonts. So Qt font compiler is another tool that will take the font file of your app and will generate another C++ file with another set of CRIs that will contain glyphs, pre-rendered glyphs for your app. And your app will decide, well, not app, the Qt font compiler will decide which glyphs to pre-render, depends on the text and the letters and glyphs used in your QML files. And only those glyphs that are used in your app will be generated in ql_fonts.cpp file. And if you are going to use more of them, there is a way to extend that, but we'll cover that later on. After assets generation, there is a process of converting your C++ interfaces to provide QML representation of those. So Ql interface generator tool will take your C++ header files and will convert those to QML representation by passing all of the properties, names, and so on to QML code that will be needed by the next step. And the next step is converting the QML files to the final C++ representation. And this is a super important thing to understand, that in Qt for MCUs, every QML file is converted to C++. And finally, the C++ representation of your UI is the thing that is running on your board. And Ql to CPP tool is converting your QML files, and those which are the your interfaces representation from the previous step, and on the output, we will have another set of C++ files with a definition of all of those UI related things from the QML. And finally, we have the compilation process, C++ compilation process. So any compiler that is needed for you, so MSVC or I don't know, ARMGCC, Green Hills or others will go there. And this will take the files, the C++ files from your application, C++ files that are auto-generated, and optionally the default main entry point that can come from common macros. Compiler will compile all of those C++ files together. And then finally, the linker will link all of the symbols together as well with adding the libraries with Qt Quick Ultralight and platform abstraction, and possibly other things that are needed by your application. Well, and finally, you will have the app that can be flashed on the board. This could be quite a complex thing, but the question, if you have any questions regarding this part, if so, then just please let me know by the Q&A section, and I will go to the next slides. And those will be about the tools that were involved in the compilation process that I just explained. And the first one, QRCC, it's a tool to convert the images to C++ representation. So it also follows some loading policies, so you can decide if your assets are located on flash or they has to be copied to RAM during the startup. This tool can optimize the image for some graphical transformations, so you can decide if particular asset is going to be rotated or scaled, and then QRCC will mark that file for the platform that this file, this asset, this resource is going to be rotated, and then the platform can do a special thing. For example, it can put that to the faster memory for faster access, and then the rotation will be faster. But this will be done on the platform, and QRCC is just following the optimization flags and also the loading policy. It will compress the image if it's needed. So as I said, even if you are providing the compressed format, for example, PNG, but you still would like to have the compressed format in your Qt for MCUs application in the runtime, it will, let's say, recompress. So it will compress the image in the format that Qt for MCUs is expecting. Some platforms have the custom formats that are used to compress the images, and it's also prepared for that. And well, yeah, the output is the normal C++ RI, the byte array, and the images are stored normally with as the bitmaps and in the compressed formats, of course, as the compressed formats, the binary format. Qt font compiler is used to generate the glyphs, and it's stored those glyphs as arrays, the alpha maps, normally in the alpha 8 format. You can change that. You will be able to change that in the future by using new APIs for controlling the font quality, but right now it's only in the alpha 8 format. Well, glyphs are generated, as I said, automatically based on what glyphs you are using in text in your app. It can be overridden. You can define and extend the glyphs range by providing additional sets of the characters to pre-render. And the super important thing, of course, is that every font size will generate another set of the glyphs. So, for example, if your app is using 10 glyphs, but you have 2 text elements, and one of them is using text font size 10 and another one 20, it will create 2 sets of the glyphs, one for the font size 10 and the second one for the font size 20. And that's also important thing if you are taking if you are paying a lot of attention to memory consumption. QML interface generator, it's used to generate the QML components based on your C++ headers. Those will be used then by other tool to connect your QML code together with those QML components. It forwards properties, signals, functions to QML directly. So you can define, for example, the public method in your C++ class or struct, and then it will be accessible in the QML code as a normal QML function or the JavaScript function. Well, QML to CPP, of course, it's used to convert every QML file to C++. Every QML file in Qt for MCUs is converted to C++. Well, this is how it works. And initialization code is also added there. So if your C++ representation of the QML component needs any initialization, it's also already there, and for you, it's completely transparent to use that tool. And before we start using all of those features, I'm inviting you to a short coffee break, which will take 15 minutes. It's also a good time for right now to sum up some things. So if any of you have any questions, please ask right now. If not, I will start the timer with a 15 minutes break. And we'll see each other after the break. No. Then coffee break. Okay. Okay, there's a question. Will we receive the URL of video recording? Sure, of course, it will be available for you. Of course, after the whole training, so it won't be available today after today's training. So tomorrow or in a few days after tomorrow's training, it will be on your email. May we have a summary of the environment variables to compile the application? Well, okay, I will just, before the coffee break, put that on the screen, and just let me a while to prepare that. So just let me do that. I will click the coffee break timer just when I will show you the environment setup. Some information about the tools that are involved in the compilation process are located in the documentation itself. There's also a quite good porting guide that normally is not related to that things, but also contains a bit of information about those. It's also available online in the same place as documentation. But well, that's it, I think. If you need to know more about those, you can always ask us on the training, during the training. And if you are going to develop the product, you of course can have support of us, and this is also part of the code that is delivered together. Okay, well, let me prepare the environment setup for you. This was the code, new file. Component before QML to CPU, didn't really understand. Okay, we will cover that later on during the training. I will for sure explain all of your questions. Let me just show you the environment setup for compilation, and then we'll go to break and we'll cover all of the remaining things in the next part of the training. All right, so we are slowly getting back. I'm not sure. I know that my friend has shared with you the answer exactly for the same. I was not able to see that answer in my question and answer section, so I just put that there, but it's no longer needed. So let's close the timer as well. Okay, so maybe before there was one component before QML to CPP. There was a question that was not clear. QML to CPP, QML interface generator. So maybe 2 words more. So this tool does the conversion between your C++ header files, which are going to be your connection with between the QML and the C++. So this tool implicitly converts your headers and those things that you're exposing in those headers to QML files, but to QML files that are not really visible to you, and to QML files that are not going to be modified by you. This is the purely intermediate change, intermediate files that are just for the next QML to CPP tool. And by doing this conversion, it is possible to connect your C++ code, your custom C++ code with your QML code. And this tool just provides a way to connect those two things together in the implicit way for you. This is the most basic explanation how it works, but we will cover that later on as well. We will do some C++ integration with QML on tomorrow's training, tomorrow's part. So hopefully it will be a bit more clear. But getting forward, let's see how to configure Qt Creator to compile your app with Qt for MCUs and then run it. And okay, so maybe let's do that directly on the Qt Creator itself. And to do this, let's open Qt Creator. You have to trust me right now. Oh, well, Dropbox links is not working. Okay. I will have to ask Jakub, my friend. Maybe he can upload the file directly in the chat. Previously, on the previous training for STM boards, it was not working for us in the chat, so that's why there is a Dropbox link. Just let me give a second. Okay, my friend is saying that this is not possible for us to share the files on the chat, directly on the chat with you, but he will prepare something extra. So just please stay tuned. Something will be for you soon. Okay, so just getting back to our Qt Creator, and here it is. Okay. So here are some configuration steps that are needed, like checking for some plugins, some MCU devices enabled, some kits, and so on. And let's verify the version of Qt Creator as the first thing. So if you have Qt Creator turned on, then let's go to Help and About Qt Creator. Click it. And let's verify that you have 4.15 or newer, but probably you will have that one. If you have this one, it's fine. If you have the some lower value there, this could be problematic, as for this training we are prepared to work with exactly this one. Another thing is to check if you have the plugins for Qt for MCUs installed with your Qt creator. This should be done automatically by the installer, but let's verify if anything bad happened. So let's click Help again and About Plugins. Some new small window should appear, and in the filter field, let's type MCU, and you should be able to see MCU support experimental there. It should be loaded, so the check mark should be also visible under the checkbox. If it looks exactly like this on your side, then it's fine. My friend just shared with you a link to the training materials in the other way, that the Dropbox link, so please verify that if that works for you. And right now let's continue with Qt Creator configuration. So we just verified the version of it, we just verified that plugin is there. And well, so this is the moment to verify if we have proper support for the boards, for the targets and the devices. Let's call it in multiple ways. And to do that, let's go to Tools, then Options. New Options window should appear, exactly like this one on my side. And then let's go. On the left side, you have the menu with the sections, and let's go to the bottom of it and to Devices. In Devices, select the MCU tab, and let's verify the configuration here. Your path should point to your Qt for MCUs installation directory. In my case, it's the default one, so drive C, Qt MCUs, and the version 1.8. Also, there is a verification done by Qt Creator, and it's displayed by the green check mark. It verifies if the QML to CPP tool is there. It was found on my machine, so Qt Creator assumes that this is a correct directory. Also, you can find support targets. Depend on what you have installed in the installer. You will have the list of available devices for you currently on your device. And here is a bunch of other STM boards. And on this training, we are especially interested in NXP boards. So we have 1050 evaluation kit bare metal, 16 bits per pixel ARM-GCC installed. So this is the one that is needed for us. We won't change anything here, but just to show you how the configuration looks like in default kit that is created and delivered together with Qt for MCUs. So the toolchain for this board is the ARM-GCC one, or ARM-GCC 8, let's say. And its path is also verified somehow by Qt Creator by checking for some executables in the directory that is provided. MCU Express IDE is used to get some tools to flash your device, and it's also verified by checking if the flashing tool is there. And as well, the SDK for the board is verified by just checking if the directory that is pointed there exists. And all of those paths are default paths of the installation that is coming from the Qt installer. And well, this is about the devices, so you can verify the configuration there, but Qt Creator should automatically create the kits. So kit is a kind of configuration that is then used to compile your app. And by default, all of the kits that are detected in the devices section are also detected in the kits automatically. But in most of the cases, there is one small problem that we have to fix, and we will fix that right now. And let's pick the Qt for MCUs. Well, maybe from the beginning, on the left side at the top, don't forget to scroll up. There is a kits And the first bookmark with the kits as well. There is a set of Qt4 MCUs kits, and most of them are with yellow triangle with the exclamation mark in this. And we are going to fix those that are needed for us on this training. And let's focus on the Qt4 MCUs 1.8 desktop 32 bits per pixel for now. Click it. Some more fields to configure should appear. And the only thing we have to change there is to change the CMake tool, because by default, Qt Creator selects system CMake, and we are not going to use that one because it's too old. So we are going to switch that to the one that comes together with Qt. It's also marked with the Qt in the braces. So let's select the CMake 3.19.2 in my case for the desktop, and let's find the kit for our board. In my case, it's NXP MIMXRT 1050 EVK bare metal, 16 bits per pixel ARM GCC. Please do not mislead that with IRR compiler. It's a different one. So let's select the board kit and do the same for it. So let's scroll down, let's review the parameters there, let's find the CMake tool, and let's switch from the system CMake to CMake that comes together with Qt. Okay, of course, if you have a different board, let's select different board. But that's rather obvious. Okay, do not forget to click apply, or just simply OK. And right now, we should have created, we should have configuration step ready. So well, maybe let's try to verify that configuration, and let's create some example Hello World app, and let's try to run it to just verify if that works. Okay, so let's go to projects, more or less in the center of the screen, and let's click new. On the left side of the new window, let's select application Qt4 MCU. In the center of it, there is only one option, MCU support application, and click choose. Let's give some name for our application. In my case, it will be Hello World. Okay, project exists in documents, but we'll change the directory. I have special training directory, select the folder. Okay, click next. And right now, this is the important thing, so please focus right now. By default, there is a desktop kit selected, but not from Qt4 MCUs. This is a crucial thing right now to disable that one and to search for MCUs targets. Okay, and let's select desktop and let's find our board. Okay, 1050 EVK bare metal, 16 bits per pixel, ARM GCC. Okay, so select that one as well, and next. We are not going to use any control version here, so we are not selecting anything, and let's just click finish. And it should look more or less like this. So let's review the QML file right now. As you can see, this is our default Hello World application and Hello World QML. We have an import. As I said, the version of import is not important for Qt4 MCUs, but it's important for Qt Creator, so it's there. And we have a rectangle of a given size. This size is exactly the size of the screen of our MCU board, and there is also text Hello World displayed in the center of the parent, so the center of that rectangle, with a salmon color and the pixel size 14. Okay, so let's try to run it on desktop first, and to do that, let's click on the left side, on the bottom left side of the whole Qt Creator window, on that thing and that microcontroller icon, and let's select desktop, debug, and click play. Brilliant. So we have our rectangle with a default color white. And of course, there is a Salmon hello world text in the center of it. All right, let's try on device. So to switch to the device, you have to click once again on that icon of the microcontroller, then select Qt for MCUs and the name of the board. Let's pick debug. We should wait a while to reconfigure the project. Okay. And right now, what I'm going to do is I will just click that start button, but I will switch the camera to switch my view to secondary camera, so you won't be able to see when I'm clicking that. But I would like to show you how the application is transferred to the board. So right now I'm going to switch my view to camera. Okay, so right now this is our purple color, sorry, the magenta color. And let me click start. I'm clicking it. So the compilation process is right now started. It compiles, still compiles. Okay. And the board is right now flashing. And here it is. So right now you should be able to see the hello world. Yeah, it's there. Okay, camera is working. Okay. So right now you should be able to see the exactly the same application on a device, and it's done completely from Qt Creator, which does all of the stuff for us. Well, this is how it looks after the flashing, so no change really. Okay, so I assume that that's it. We have went through configuration steps that are needed for Qt Creator. It mostly does all of the things for us automatically. We just have to verify if anything is broken, like for example, those CMake configurations. But in general, everything is up and running since the installation. Well, so let's go to another live coding session, sorry. And what we will be doing and what we will learn during this live coding session. We'll for sure learn how to use built-in controls, some kind of buttons or sliders. We'll see what are those compilation artifacts. So we will see what Qt for MCUs does during the compilation process, what are the intermediate files, how to understand and how to treat those files, what it comes with, and so on. And of course, how to use the CMake interface, as we will be working a lot with the CMake, as it's the default one for Qt for MCUs projects. Okay, let's review the whole thing that we will be doing during the next live coding sessions. Our goal will be to create a coffee brewing machine, some kind of a menu possibly for the machine that you are probably all familiar with. There will be a splash screen at the beginning that will have the start button, and after clicking it, will be redirected to coffee selection screen, on which we will have few different types of the coffee to select. And after selecting one of them, there will be a coffee parameters screen with 3 sliders to change the properties of the coffee, and with a button to start brewing. And the brewing will be, of course, simulated. We won't brew the coffee for real, And that will be done by displaying some progress bar that will be filling up during the brewing process. And of course, there will be some simple history for the machine, and the language change many will be also needed because we will learn how to translate our application later on. And those screens that you are seeing on the screen right now are the screens that we are going to implement during this whole training. And by doing this, we will learn particular features of Qt for MCUs. All right, so what do we need? We need for sure Qt Creator, because all of those things we will do in Qt Creator. Let's close the previous Hello World project. This is not needed no longer. Let's clear this. Let me prepare for it. Okay. So let's create another project, and as previously, let's select application Qt for MCU support application, and click choose. First of all, I will change directory to our training directory. Let's switch the name for our app. We'll be using that quite often, so it will be easier for you to follow exactly with the same name if you are following my live coding sessions. And we will call it Coffee Maker. Okay. Click next. Okay, and this is once again that super important moment to disable default desktop kit. And let's find those two kits that are needed for us. So Qt for MCUs 1.8 desktop 32 bits and MIM XRT 1050 EVK bare metal 16 bits per pixel ARM GCC. Perfect. Click next. We are not using any version controls, so just click finish. And we have that pretty rectangle with our hello world as previously. So maybe let's remove that text and let's create some rectangle, but not white. We would like to have some more coffee color, and it will be brown. Okay, some pinks, and okay, dobra. Well, let's try to run it on desktop to verify if the rectangle color has changed. So let's select the kit for desktop and debug, and let's click play. Perfectly. It looks exactly as expected. The screen size is as needed, so we don't have to change that. The color has changed from white to brown, and that's great. Let's close it, and let's try to add the another components. Let's implement our application simply. Okay, we will need the separate QML file to define our splash screen, and let's do that on the Coffee Maker project on the Hammer one. Click right and click Add New. We are going to add the QML file, so let's go to Qt and to QML file Qt 2, and let's click Choose. We have to provide a name for it, and it will be splash.qml. Okay. Click Next. No version control, so just click Finish. And as you can see, this is not a mistake that Qt Creator has redirected us to cmakelist.txt file. And why? It's because Qt Creator is not managing the CMake files for us. We have to extend, modify those by ourselves. So once you're adding the QML file to the project, even if Kit Creator provides the wizard for it, you have to manually add that one to your QML APIs. And this is done by just extending the target QML sources macro with another new QML file. And in our case, it's splash.qml, which goes there. Okay, let's wait for CMake files regeneration. Okay, and as you can see, the splash.qml has appeared on the left side, and right now it's an empty file with just an item, which is just a container. It's not drawing anything on the screen. It's completely transparent thing. And okay, we are going to use some controls on it, so let's implement that. And to use controls, we need another import Qt quick controls. The version is not important, so we can put there anything. And before adding any controls like buttons to the content of our splash, we have to provide a library with default styles for our controls. And to do that, we have to go back to our cmakelist.txt file, and we have to link the application together with the default styles library. And to do so, just before that if else and if statement, let's put target link libraries for Coffee Maker, and it will be cool quick ultralight controls style default. Okay, let's save the file. Okay, configuring as failed, so probably I made a typo. Target was not found. Coffee maker quick ultralight control style. Oh, well, yeah, I made the typo in ultralight. So right now it should be great. Okay, so we have to link our Coffee Maker application with a cool quick ultralight controls style default. Okay, right now it should be set up and ready. And let's get back to our splash.qml file. And inside that item, let's create some ID, which is the root. We will need some event to pass the situation when our user is clicking the start button, and to expose that event outside this splash.qml file, we will need signal, which will be clicked. Okay, it will forward our button event outside the control. I would also like to have some logo and the button stacked one under another. So to lay out those elements in that way, I will use column, which will place the elements one under another. And column itself will have to be aligned center to the whole screen. So I will align it with anchors. Its top will be aligned to parent top. Top margin will be 40. And horizontally, we'll center that one to the parent as well. And you can wonder, what is the parent? Parent is a property of each item which refers, well, to the parent. Probably it's the obvious thing, but just to mention that. And we would like to have some space between the elements in the column and let it be 14. 14, spacing 14. Okay. Right now, we don't know how to use any images, assets. So let's create just a placeholder for it, for the logo. And I will create a rectangle with ID logo. Its width will be 200 and height 1:1. Some different color. Maybe some purple will be great enough. Okay, so we have a tab for our logo. And right now, just last thing for our splash.qml will be to place the button there with an ID. Start button on course. We have to align this button to the logo, so to have both things on the center. And to do that, I will use anchors with horizontal center to align logo horizontal center as well. Let's display some text in the button. It says start, and we would like to receive the event when the user is pressing the button. Sorry, my voice is not getting that amount of talking today. So if I'm talking too quiet, just let me know. On clicked event handler, signal handler will just forward the event to root clicked event, the one from the top that we have created previously. So if anyone will click the button, and then we will just call the click signal that can be watched outside the splash. Okay, let's save the file, and we would like to use that splash.qml component somewhere, and probably this will be the best place for it. So our root QML file. Let's create some space for it in the root rectangle, and this will go directly there. Sure. So to use that splash.qml component, we just have to call splash, and that's it. It's our component that is defined outside this file. Its name, it's always the same as the name of the file without the extension. Let's give it some ID, slash. Anchors will tell that this slash control will have to fill whole parent. Okay, I see that there is a question. Let me just finish adding the splash and I will answer this. It's visible by default, but we'll manipulate the visibility of that one. So I will just put that there to make it more visible, that we will be manipulating the visibility. And on clicked, signal handler will hide our splash screen. Visible false. Okay, let me show what is the question. Do anchors work the same way as regular QML? Also, are layouts supported? Yes, anchors works exactly the same way as in regular QML, and the layouts, well, I would like to not lie because I'm not sure, but layouts works with that exception that I'm not sure if the functionality is fully covered on Qt for MCUs. At least part of it is supported, but I'm not sure if all of it. Right. So getting back to the implementation. So we have added the splash screen on the root QML file. And we just defined the splash screen with an ID. We told that this splash should fill the whole parent, so the whole screen in our case. It's visible by default, so we just put that there to make the code more verbose. And on click, the signal handler is just handling the pressed event from the user, which hides the splash screen. And let's verify if that works. We are leaving the desktop and the build configuration, and let's press start. Ta-da! Perfectly. We have a new splash screen on our application, and right now it looks pretty ugly. But we have a stub for our logo. We'll learn how to add the assets later on today. And there is a start button which should hide the whole splash screen. Let's verify that. Perfectly, it works. So do not getting things longer. Let's try that on hardware. And to do so, let's click on bottom left side, the icon of the microcontroller. Let's switch to the kit for the NXP 1050 or any other board that you're using. And let's keep debug and let's press start. Okay, I'm switching the view to another camera to show you how that will look like on the device. Here it is, still the old application with the hello world. It's still flashing. As you can see, the flashing process is taking quite a bit of time. So it's once more the moment to mention that desktop backend is something really important to work with UI and with designing the UI. It's a pretty useful thing to verify the simplest changes and just to verify the performance or the more crucial things on the hardware. And as you can see, the application is right now on the device. I can check if touch works there perfectly. When I press the button, everything disappeared. Let's verify once more by resetting the board. Perfectly, it works. Okay, let's get back to sharing the Qt creator. All right. And right now there is a moment when you will have to use the files that we prepared for you in the training materials. So I will give you a moment to open those. And I will give the moment for myself to find those. Okay, there is training and the training materials. Okay, and getting started. Okay. So here it is, and how it should more or less look also on your side. And the directory that is important for us right now, it's the one_coffeemaker step 0. Let's get inside and let's review what's there. And sorry about that. Each step that we will be doing in our live coding sessions will contain both two directories, the files and the solution. The files is the directory that contains some prepared files, but still unfinished content to speed up development of our application. Those files will contain mostly some utility functions, some basic QML implementations that are not that important for this training to demonstrate the features that we are learning, but just to speed up the things to boost our development velocity, to focus only on the things that are needed. And the solution directory contains the whole solution, the proper state of the application after each live coding session. So after this live coding session that we are right now following, we will have exactly the state of this directory. So if any one of you will get lost during those live coding sessions, you can always get all of those files copy them to your project and replace all of the files that are in your Coffee Maker project. And then after compilation, you will have exactly the state as we will have after each live coding session. So this is a quite helpful thing if any of you will get lost or will like to have some kind of reference to what we are going to. And in the files, as I said, these are the files that are prepared just to speed up the things. And let's review what's delivered in those files for the first step, for this step 0, let's say. So this is a font. So we will switch default font to use well, more fancy one. But well, just to show you how to switch the font, really. There are some helpers that will provide some utility functions, some margins, colors, and so on. And some QML files that will provide some basic implementation of the parts of the app that are not so important from the Qt for MCUs training perspective. Well, so let's select all of those, copy them, and let's go to our Coffee Maker directory, and let's paste all of them. Perfect. If anything will need replacement during the training, just please do that and replace all of the files. All right. And right now there is a moment to modify our application project to add those new files and new things to the compilation. So let's go to the cmakelist.txt file. And right now we have to add all of the new QML files that are going to be used further. So in target QML sources, let's just add all of those new files. And this is backbutton.qml, coffee parameters.qml, coffee param group.qml, coffee selection.qml, coffee selection button.qml, and the coffee param slider.qml. Perfect. Okay, and let's save the file. All of those new files should appear on the left side. Here it is. Okay, and right now let's focus on changing the fonts. And before target QML sources, it's super important thing to add this before QML sources. We will switch the font. And to do this, we will set some properties on the project. Set target properties, of course, for Coffee Maker. Properties, default font family. It's Roboto. It's the font that is delivered together with the training materials. Okay, so right now we just defined which font family should be our default one, but we still should tell Qt for MCUs where this Roboto font is located. And it's located in the directory of our Coffee Maker application. And to do this, we are just going to set another property. And right now we will use set property. So this is a different macro. And target Coffee Maker append property Q fonts dir, and then we'll use some CMake variables as well to reference the source directory. So just a $, curly brackets, and inside curly brackets right now CMake underscore current source dir. Okay, and outside the curly brackets /fonts. Perfectly. So this is about the fonts. And as I said before, to create a singleton, we need to create additional module. And the files from the helper directory, let me show you once again which files we are talking about. In our application project directory, there are helpers, and those helpers are singletons. So we have to wrap them in separate module. And to do so, we have to define that module in the CMake list.txt. And we are right now just doing this. Okay, somewhere below, qul add QML module. Let's open braces, and this will be different modules, different target helpers underscore module. Okay, and it will take some arguments, of course. First argument is URI helpers with a capital letter. Second one is the QML files. And those QML files are helpers / limit.qml helpers / helper functions. Also .qml. We would like to switch output directory. So output directory argument $sign curly brackets, and inside curly brackets we are using another CMake variable, CMake current binary dir. Just please pay attention, that's a different thing from that one above. Previously it was CMake current source dir, and this is CMake current binary dir. Okay, and after curly brackets, outside them, let's put /helpers module. Okay, and generate QML types. As the last thing, let's save the file. Hopefully I didn't make any typos. For now it looks okay. As you can see, on the left side we have also a helpers module as a separate component in our project. It's because we just defined that module there. And okay, and to make the Qt creator happy, we can provide additional variable that will tell where Qt creator should import from our helpers module. And to do this, let's set just one variable, QML import path, and once again $sign curly brackets, and inside curly brackets CMake current binary dir. After curly brackets, outside them, let's put /helpers underscore module cache path and empty string. That's not that important. It's just for Qt creator to make it happy. All right. Well, and this is almost everything. But we have to link our helpers module to our application. And to do so, we have to provide helpers module in the target link libraries, but we have to move it downside to make it visible for it. So I'm just cutting the target link libraries line, and I'm pasting it under the qul_add_qml module. And right now I can link it to our app by just providing helpers module. And that's it. And trust me or not, it should be enough to try it. So just keep in mind to switch again to desktop. So once again, this MCU icon, and let's select desktop debug. Let's wait for CMake to regenerate, and that's it. Here we go. Let's click start. I see the question. Just let me, well, okay, well, let me see that it works. It works. And let me see the question and answers. Well, so let me answer first the question, short one. Is the module a lot like QML plugin, meant to be a standalone add-on? Well, I'm not sure I'm able to answer it that way. So the module in this case is just a separate static library that is in fact linked together with your application. I'm not familiar that much with a big Qt approach, and if that can be a standalone add-on. But well, you can technically create just a module which then you can redistribute to others. It's completely possible thing, but keep in mind that it will be in the binary form, so it still will be the library that comes with some precompiled things. Well, so technically it can be a standalone add-on, but it will be precompiled for some particular target, for example, for that NXP 1050. So you can create, for example, some library with controls, with helpers, and so on. But it will be meant to be used with just a single target, I think. And the second problem, unfortunately, I have not succeeded to run an application on desktop yet because of this error. Okay, CQ tools CMake. Let me just review quickly. What's the error? Current configuration missing CLANG and MSVC. This is not supported. Is there anything I'm missing? Well, so my answer to this is, please verify if you are using the proper compiler for the proper version of the MSVC. Second thing is, please verify that you don't have any old Qt paths added to environment path, as this is a quite common issue that this kind of problems appear if you still have some old configuration of environment still on your device. And the third thing is to verify that your kits that I was showing before. Let me quickly show that once more. So tools options. Please make sure that your kits, then kits bookmark, and then let's go to desktop. Please verify that your CMake tool is CMake 3.19.2 from the Qt installation, not the system CMake. This is the best I can help you right now with this. Please verify those things and let me know if that helped. Well, there is an answer to the previous thing. Yeah, well, that makes sense. Okay. Okay, so as you can see, let's run it once more. We successfully added things to our application, but still we are not using anything of those. And right now there is a point to make use of those additional things we just added. And well, to do this, let's open the main root file, coffeemaker.qml. And we would like to have some coffee selection screen just after we are going out from Splash. Well, so just under the Splash, we are going to add coffee selection. It's one of the additional things that comes with prepared files from training materials. With an ID coffee selection, just keep in mind that this has to be from the small letter. Let's put some anchors and let's fill the whole screen again. And by default, it will be invisible. So visible false. Okay, so we have that right now there, and we would like to show this one once the splash is not shown. So coffee selection visible equals true. Okay, it looks like it's ready to be tested. Let's click start to verify that, and let's click start. Perfectly. Still, we don't have and we don't know how to use images. That's why we have that pretty ugly things with the colors. But this is still not doing anything, and we'll change that shortly. Let's close that. And right now we would like to see some customization screen once any of the coffees is selected. And once again, let's go to coffeemaker.qml. So maybe let's not go to this, but let's stay in that one for a while. And right now, let's add coffee parameters screen with an ID, coffee params. It's also visible false by default. We don't want to see that once application is started. And on course, let's fill the whole screen parent perfectly. And this screen has some functionality to get back, and it's exposed by the signal back. So we can watch that signal by providing the signal handler on back. And we would like to hide that screen for sure. And so coffee params visible is false then. And we would like to get back to coffee selection screen. So coffee selection visible equals true. All right. Okay. Okay. So this is visible. Okay, on back. Should be it. But right now we still need some event to know when someone clicked for and selected particular coffee. And coffee selection screen has another signal that we can watch, and that's coffee selected. And we of course can watch it by providing on coffee selected signal handler. And in that one, we will prepare some parameters. So coffee params. Well, let's tell the params screen which coffee has been selected by filling its property coffee index. Okay. And this should be equal coffee index, which is sorry, really my voice is not getting it. And the coffee index is referring to the parameter that is to the property that is owned by coffee selection component. And we are passing that coffee index to coffee parameters component by just filling another property which is defined in coffee parameters module. So we just told which coffee has been selected, and right now let's make some screens visible and some invisible. Coffee params will become visible right now, and coffee selection will become invisible, false. All right. So let's try to run the app and verify if we didn't break anything. So we have a splash screen started. We have a coffee selection screen with a nice grid. And let's pick cappuccino. And brilliant, we have some ugly screen for selecting the properties of it. There are some sliders that are working. It's strange. Of course, I'm joking. But well, we have our things ready. As you can see, the coffee is also passed as we selected cappuccino. And if we go back and select espresso, it's also visible there. So we are properly passing the selected coffee index. But that star button is still not doing anything. But before getting more into detail how to extend the app, we'll review the build artifacts for our application. To do this, maybe let me open the Visual Studio Code in the directory of our training one, in the training directory. Okay, select the folder, do not save anything. All right, this is our training directory. Maybe it's large, not too big. All right, and this is our coffee maker directory that contains all the sources. And Qt Creator has created for us some build directories outside that one. And I will right now go to, well, maybe the most recent one. So the build directory for coffee maker, Qt for MCUs 1.8 desktop 32 bits per pixel debug. And there is a, okay, there is a chat message, but it's just from the previous message. So let's continue. And in that directory, let's collapse the others. Let's go to CMake files, the build directory, CMake files, and the coffee maker.dir. And let's review some of those files. Most of them are following the same rules. So I will just cover single file from the single rule, as it doesn't make sense to follow all of them. And let's see what's inside our splash. So we defined splash.qml file. So what's after the compilation process? You can find the splash.h, for example, which defines for sure the splash type, which is a struct. And let's maybe enlarge it to, oh my God, there are some zoom steering icons. I cannot see the whole screen. Okay, let's leave the splash.h there, and let's open the splash.qml file that we have created. All right. And in split view, perfect. So as you can see, what we did in QML file, we just created the item in the root, and there are some IDs, some signals. There is a column, and some other things. And what is inside our splash.h file? We have a struct with a name splash. And this is inheriting the item, so it's inheriting the root item from there. And if you are looking closely, there is also some there are also some objects defined there. This is the struct that initializes the logo placeholder, which is the rectangle there. This is also the start button, which is a button with the ID start button, exactly as in the QML file. There is also a property of signal that is called clicked, exactly as in QML file. And this rule is for all of the things that are converted from QML to C++, but it's completely transparent for you. You just have to understand that this is happening. You do not have, and you're not allowed to modify those files. Those files will regenerate each time you are doing compilation. Okay, there is another question, maybe the silly question. Can't we have a signal and slot mechanism in completely a GUI manner here at the Qt for MCU to deal with events? Here at Qt for MCU to deal with events. Well, I'm not getting that question, to be honest. So what do you mean in the GUI manner? I'm not sure if you're able to create the signal and the handler for it completely from the GUI for Qt for MCUs, but well, you just have to use it from the QML. You have to define it there, and then well, simply watch it in different place. I'm not sure if I'm answering your question. Probably not. But if you can ask more precisely, then maybe I can answer better as well. Well, let's review the C++ part of it. So, well, what do we have here? There is all of the initialization process for the whole components. So some bindings for anchors are set there. Some spacing for the colon is set there to 14, exactly the same as in the QML file, and so on. Just as you can see, the QML is directly converted to the C++, and this is about the components from the QML that we're creating. Another interesting file could be coffeemaker.cpp. It's exactly the same as for the splash.qml splash screen. So this is the equivalent of the coffee maker.qml, and I won't follow those all of those things because well, it's the same as for the splash.qml. And another interesting thing is the font engines. And here you can clearly see what Qt font compiler does. So it converted the string, the only string that we are using, maybe not right now the only, the strings that we are using are analyzed, and all of the glyphs that are used there are converted to that glyph array. And that array is just an array of alpha maps, which are then defined there. And Qt for MCUs is implicitly, of course, for you, is implicitly using those alpha maps to place one after another to produce the text for your controls. And just please keep in mind, once again, I will remind you that every font type and every font size will produce another array that will be compiled in your application and will consume the memory. This is a crucial thing to understand this while working with MCU devices. And here we have even the example of it. So above we have the Roboto font of size 12. And if we will scroll down a bit, there is a Roboto of size 19. And maybe we'll find another one. Yes, a Roboto 20. This should be used with a special care. And we have to pay attention while creating an application for MCU to not consume too much memory, and we have to use fonts responsibly. Okay, this is about reviewing those artifacts for now. And that's it if it goes about first live coding session. So right now we are approaching the first lunch break. And for those who are going to eat something, this is a moment that you can go and just get some rest, get some food, and eat something. For those who still have some questions, some not clear things, some problems, technical or something, I'm here. I'm not getting for a long break. I was eating before the training, so I don't have to do that right now. I'm here for you to help you. So as I said, the lunch break will take 45 minutes from now. And for those who are going to take that break, the time is starting now. I'm putting the timer. And for those who are still curious about some things, I'm here to help. And I will try to answer all of your questions that are still not solved. Okay, so this is a timer for the lunch break, and I'm here. If any question is still there, just please ask. All right, so we are back after the lunch break. Hopefully you are a bit more rest right now. As the first thing after the break, I would like to thank you for the feedback and the chat. I would like to be better in the places that you think it could be improved. Well, that's it. Thank you very much again for letting me know that some parts were too quick or something. If you have any more thoughts, feel free to tell me that on chat or whatever in Q&A. But right now, let's focus on the next topic, which is asset management and what it means if it goes about asset management. So right now we will learn some of the CMake APIs that are used to embed your images to your application. You will learn how to control the size of your images in your apps and by using which APIs you can decrease their size, for example. But first of all, let's focus on the QAD resource, which is used to pair your files, your assets, typically the PNG, JPEG files, or any other files that can be handled by QImage, in fact, which is used underneath in the tools to parse those files, to regenerate those to file formats, to pixel formats, and to image formats that are known for Qt for MCUs runtime and can be used there. And just to remind you how the CMake API for adding those resources look like, this is the QAdd resource macro, which as a first argument takes the target, so your application name typically, and then there is a list of the files. As I said, the PNG, JPEG doesn't matter. Most of the most commonly used formats are supported there. There is a prefix path, a base path, and the output directory to redirect the artifacts, the converted output that is the C++ source. But let's focus on the base and the prefix, what there does. So there is an example of adding the image1.png to the my app. And as a base, we provided res. And why we can use that, for example, to shorten the paths in the QML. So if you have a long path that your images are in, you can shorten that to just omit that commonly used part. And there is some message in the chat. Thanks very much. You're welcome. Yeah, as I said, so base argument, it's an optional thing. You don't have to provide that one, but you can shorten the paths in the QML sources for it. For example, and by doing this, the code will be more clear. And well, you can always manipulate the base as well to, for example, have two sets of the assets for different resolutions. Let's imagine the situation when you have the application for two different microcontrollers, one slower and one more powerful, and the more powerful one have a bigger screen. And well, to save some memory on the low-end device, and well, to adjust the images to size of the smaller screen, you can have those in the images located in the directory with a different base, with for example base small res and the big res, and you can change the base argument depends on for which board you are compiling the sources, and then your QML code will look exactly the same for both, and you will just manipulate the base path for the particular boards. So it could be quite useful. Let's see how the prefix works. This works in the other way around, so it adds new prefix, as the name is saying, to the paths. So it forces you to use that prefix before each path to the image or resource that you are using in the QML. And well, it's in addition to the first one, it can be used for similar things to just manipulate your paths with something constant in the front of it. You can combine both things. So in the same time, you can provide a base to reduce the path and extend that one with a prefix. So you have some kind of a mixed behavior there, and you can adjust those for your needs. If it goes about asset management, there are also a couple of resource properties that are quite important. So there is a QUL compression. And if that parameter is set for particular asset, as all of those parameters can be set per one asset. So you can set them globally, but of course you can also set them exclusively for particular files independently. And what the QUL compression does, so this marks an image, an asset to be in compressed format in the binary. This will mean that this image will have to be decompressed before the rendering, and well, by doing so, you will save some memory on a device. So your application will take less memory in RAM in the flash, but it will take more RAM, for example, during decompression, as those decompressed data for a while at least has to be somewhere. And this is where the image cache comes into the game. We were talking about image cache previously. There is some mechanism to store dynamically prepared images, dynamically copied from flash to the RAM for faster access, or decompressed images are also located in the image cache, and QUL compression does the magic to store some particular assets in the compressed format in your binary. Well, the rendering will be slower, but it will consume less memory, so it depends on you which you favorize to have less memory used or to have more performance. But it all depends on the hardware you have. In some cases, so some particular devices have hardware decompression modules, so you can accelerate those, and Qt for MCUs will do that for you if there is any decompression unit available on the board. But well, as I said, this depends on your needs and your board and device. It's more like the platform dependent thing, and you can decide whether to use it or not. The next thing is QUL copy to RAM. So this marks an image to be copied to RAM for faster access. Most of the flash memories are rather slow, and usually copying some data to the RAM and accessing it from there is much faster. For example, if you are going to rotate some images or scale them or do anything of any kind of transformation on those, it could be wise to set this property on them, to copy them during the startup to RAM, and then access to those assets will be much faster on every device. But as well, in this case, it depends on you if you are going to do so, as every device is different. For some devices, keeping assets on flash is enough. For some, it's not enough, so we have to accelerate it somehow. And that's when QUL copy to RAM comes into the game and can help you with achieving your best performance. QUL image color depth defines the quality, the color depth of the image in which it's stored on the in your application binary. So, for example, by default, it will every asset will be stored in the best possible quality, but you can decrease it explicitly by using this API to reduce the amount of memory that it will consume in the binary, in the flash, in the RAM, wherever it will be located, but it comes with lower quality. So if you have the high quality 32 bits per pixel image and you will decrease it to, for example, 16, of course, some gradients or some more detailed colors will be reduced. You'll optimize for rotation and for scale. Those two properties are the optimization properties, and this is working differently on each board Qt for MCUs supports. It depends only on the platform implementation, on the platform adaptation part of Qt for MCUs, what to do with the images that are marked with Qt optimize for rotation or for scale. And most commonly used approach is to store those images in some faster memory. But some of the platforms can, for example, have some special formats that are prepared for faster rotation or scale. And this can be achieved by using those two properties to mark that this or this asset will be scaled or rotated, and then platform will decide what to do with those assets to really accelerate those operations. Each of those parameters I just told you about has also equivalence of default Qt default variable or the parameters. So if you are going to use every image as a compressed one, you can define the global value Qt default compression to true or to on, and you don't have to provide the Qt compression property on each of the assets you have. And this goes about the same for each of those parameters, which of course can be then overridden still. So if you are going to use compressed images for your whole application, you can still disable that compression for a single one by just setting Qt compression to off on this particular asset. As in this example, we are setting default compression to on, so all images are stored in the compressed format, and then you are setting for knob-handle.png property Qt optimize for rotation to on, and for the background.png you are setting the property Qt compression to off, and then that background.png will be stored still in decompressed format as a bitmap. And this is, if it goes about asset management, more or less, we'll go into more detail during the live coding session, in which you will learn how to add resources to your application. We'll have some new images for buttons, for logos, and so on. We'll see how to change resource file attributes, and we'll review what's the outcome of compilation if we have assets included in our app. Well, so let's get back to Qt Creator. Here we go. That was fast. Okay, I'm not helping myself, so just let me prepare for it. Okay, and we will be using step 1 from our training materials. So just before live coding session, I will remind you how it works. Right now, we will be using _coffee maker step 1. And this is the directory that contains files for this particular live coding session and the solution for the whole one. But if you are lost during the previous one, you can still align with us by going into step 0 and picking solution. And this is the state we currently have with our application. Let's review how it looks like right now. So without any changes, just getting back to previous session, let's choose debug. Let's start it. We have a splash screen with a stub. We can start our application. There are some buttons for selecting a coffee type. Let's select Cafe Mocha, and we see that we have the parameters screen, and this is all. We can always get back and select other coffee, but nothing more is working right now. Maybe let's verify that on the device. So to make sure that this state is also working fine on the NXP board. Okay, I'm just hitting start. I switched the kit, of course, previously, and let me share the view from secondary camera. And this is right now the disabled splash screen from the previous run. And okay. And of course, that is not working for some reason on the device. Let me quickly review the problem. I will try to clean the solution and rebuild it. Oh well, my toolchain just decided to stop working. Oh, I will show you what is the problem exactly. My board is my compilation for the board is even not working right now, and to be honest, I'm not sure why. Let's try to align with the step 0. So I will pick the solution for whole. Okay, training materials, training coffee maker. And replace all of those files. Okay, reload all, and let's try to clean it. I'm really not sure what happened as it was working just before. Okay, let's debug, okay. Let's try to build that. It's not the best thing I would like to see right now. This is happening always during the live coding sessions. It started after importing the files from step 0. Okay. It's quite an interesting thing. What is happening to those things? We are not really. There's targeting libraries there. It should simply work. It's very strange. Did it happen after adding the QML files or adding the module? Okay, this is link there. It shouldn't really matter, but let's try to. There. Right now, Helvers is not working at all. Okay. Let's try once more. It's some problem during the linking process, and it's really, really strange. It should link those both things automatically by calling the QLAD target, but let's remove that. Still the same. Let's try in the release mode. Okay, the release mode works, but for some reason we are not able to run debug. Let's see if that will work. Okay, the release mode seems to work right now. I'm not sure what happened. It's a bit strange for me. Well, I will get back to you with the answer for that strange thing later on with the follow-up email. But let's not waste the time of this training to understand right now what was the exact problem. Just let me know if the release mode helps on your side as well. I will just share the screen of the okay, thank you very much for the hint with removing directory. But before I will test that just to show you that the application works exactly the same on the device. We can also switch the slider values. Of course, start is not working. Let's get back. Select different coffee and let's get back again. Okay, perfectly. I was not expecting to have such big problems, but hopefully, well, it won't break again. So, okay, we have a state ready. So we can try to add the files from training materials. And this is the step 1, as I said. And let's go to files. Let's review what do we have here. So we do have update for helpers. We have additional resources. As you can see, there is some image for a back button in 2 states, for a pressed one and for a normal one. There is a couple of images for selecting for coffee icons. there are also some assets for the logo. There's some background. Those are the files that we are going to add, and some new components. Well, the updates for the components we previously also copied. So let's get back to training, to our coffee maker machine, and let's paste that there and replace the files if that's needed. Okay, let's minimize. And this is a moment for adding those resource files to our CMake lists.txt. And hopefully right now it will work. But this is how live codings works. Okay, so just in the CMake lists .txt, let's introduce cool add resource. Coffee maker and files, and this is the place for adding the resources. So here we will add all new files, all new PNG files that are located in the resources directory right now. Button back normal.png. Let me copy that resources. We will have to add that here a lot of times. Button back down.png resources logo big.png resources. Okay, it's there. Logo small.png main.dash-background png. Yeah, and now we'll have coffee icons, cafe latte.png, cappuccino.png, espresso.png, ristretto, cafe mocha. I'm feeling like in the Starbucks like right now. Sorry. And latte macchiato, yeah, well, the most popular one. Latte macchiato.png. Oh well, right. And we can make use of the base parameter to get rid of these resources in each of our files. Just put resources there, and let's close the brackets. Okay. Okay, here we go. That should be it. Well, let me compile this thing, as I do not trust if I didn't break anything. And okay. And linking. No, it's still building. Okay, it works. Okay, I will switch to desktop right now, as we will be testing our changes directly there to save some time. And as we have added all of those PNG files, I will try to add some background for our application. So in the coffeemaker.qml, we are right now removing the brown color, as we won't need the solid color for now. And also we won't need the rectangle no longer. So we are replacing it with an item. And why is that important? You can think that, okay, but this image will cover whole screen, so the color won't be visible at all. But for some platforms, it's a crucial thing, because if you, by some mistake, can create an image that, for example, is not fitting the whole screen exactly for at least 1 pixel, or is semi-transparent in any place, it will cause red row, the background in that case. And for some low-end devices, it can be simply problematic to render that on time. For devices that are using the double buffering, it's probably not that big problem because it will be a bit slower probably. But there are also some devices that have not that much memory to create a double buffering. So you have to fit in a particular piece of time to render the whole frame. And for such devices, this could be a quite problematic thing. So it's a good practice in Qt for MCUs to get rid of the things that you're overlapping and you're not going to render at all. And the item is just a container that is not rendering anything. So by removing the rectangle and its color, we just get rid of the background at all. And right now I will add an image to be our background. And this is the image. Let it fill the parent. It's the size of the screen, but just to keep the consistency with other screens, source will point to our background by just typing qrc main bg.png. Save. All right, and we can try to run our application on the host machine. And let's see if that works. And that works. Let's try to start. And we slowly can see some differences as we have new small logo there, which replaced the placeholder. And also the splash screen is showing the background. I was about to say that it's showing the logo as well, but we will do that just right now. So to add logo to our splash screen, let's go to splash.qml. And inside that, we have to make some change to the placeholder rectangle. So let's make it image. Let's leave the ID. Width and height are no longer needed. Those are coming together with the asset itself. Color is also not needed. And the source is qrc logo big png. Well, let's verify. Brilliant. We have our logo on the splash screen. We can start the app, and here there is also a small logo. Let's try on the device release mode, as debug is not working for us no longer. Okay. Switch cameras to show you how that would look like on the device. Application has built successfully, so right now there is a flashing process. It will take a bit more than previously, as we are about to flash the bitmaps that are right now embedded together with the application binary. So each image that we are adding, of course, is expanding the size of our application binary. It will take more space on the flash memory, as we are keeping those by default on the flash. And our microcontrollers are drawing and reading those assets directly from there. Here we go. We can see that the asset is finally drawn on the device. We can verify on another screen. There is also a coffee logo, the small one, on the top of the screen, and nothing more changed. So let's get back to sharing the screen. And it's a good moment to review what happened with those images. And right now I'm opening once again the artifacts for our application, and I'm just right now browsing the main training directory, and I'm going to the desktop build directory, and let's find the assets there. And for example, let's pick the logo big. Okay. And as you can see, as I said to you before, those are kept in the bitmaps, the raw bitmaps that are just arrays. Okay, it's quite a big one, and what I'm also going to show you that this logo is semi-transparent, so we have to use the format that is keeping the alpha channel. And here you can see that ARGB32 is the format that is used to keep that particular asset on our in our application. And one cool thing about the Qt4 MCUs is that Qt4 MCUs build process is able to optimize your assets. So, for example, if you are going to display a gouge on the screen, for example, in the car, in the driver's display, let's imagine the gouge that have only a ring, and the most of the content of that image is completely transparent. So you don't have to store that fully transparent pixels, as those are mostly the zeros. And Qt4 MCUs during the compilation process can split the image to separate parts to save memory and to not include that empty parts of the image in your app. And this is done completely implicitly by the tools during the compilation process, and that significantly saves you a memory while working with huge semi-transparent images. As you can see, even right now, we have two parts of that big logo. So our tools detected that there is a possibility to save some memory, and it cut off some transparent places that were not needed, and we are saving some memory by this. And this goes about the same for all assets that are included to our application. Okay, so let's try to modify application a bit more, to add the icons to our coffee selection screen. And to do so, let's try to open helper functions. We will need to provide additional helper function to select the image depends on the index of the coffee. And right now, how the color is picked is just by calling the get coffee selection button color. It's line 89, and this function is just taking an index of int type, and it's returning a string with a name of the color. And we are going to create this exactly the same function. Exactly the same function. So I will copy that one, but we will return the assets instead of colors. So first of all, we'll need to change the name of the function. For our, in our case, it will be get coffee selection button image instead of color. Let's pick the same argument. Let's return the string, and let's focus on providing proper assets there. So QRC, and maybe let's copy that with a slash already. So for the 0, it will be PNG QRC. It's also possible to use assets with index included in the file name, and then you can also concatenate these strings and combine the index together with a first part of the string, and then just append the extension. But we do not have such naming in our assets, so we are just creating some simple switch case. QRC espresso. Macchiato and cafe latte.png. All right. And okay, we have our helper function ready. So right now let's make use of it. So let's go to coffee selection button.qml and let's see what's going there. Okay, so there is a property color, item color, that keeps the current color for single button in our coffee selection screen. So let's create similar one for the image. Property image. And it will be called item image. And from helper functions, let's get coffee selection button image with coffee index as an argument. And let's see that coffee index is just a property. And if anyone will change that coffee index with any new value, then the binding that is created there will update the item image property by retrieving the new value from that helper function by providing the new value of coffee index from the binding itself. And the color will be no longer needed. So let's remove it. Okay. And the last thing is to replace the rectangle placeholder with the image. So let's rename it image. Width and height is not needed. All right, color as well. And what is needed? Source is needed. Source will be just item image. Okay. And we would like to have some feedback on the click. So I will create an opacity change, which will be done in some trick way for those who don't know how the bindings in QML works. For those who know, it works the same as in the big code, but for those who don't know, it works by this way. If you will create there some, let's call it expression, mouse pressed. So I'm creating expression to check if mouse is pressed, and if it is, I will set the opacity to 50%, and if not, to full. Just to reference the mouse, let's give an ID to mouse area, ID mouse. Okay, and this expression, as it's the binding pinned to the opacity property, will update every time when only the property of mouse that is called pressed will change. So any change on the pressed property in this binding will cause refresh of the opacity property in the image. This is a cool way that allows you to create clean and easy to read code to express your UI interface. And okay, this is about the button, and let's try to add also that image of selected coffee to parameters screen. So let's go to coffee parameters.qml, and there is a place, and well, yeah, here where there is an image prepared already for you, and we would like to have an image here. So once again, we are using our new helper function, helper functions, get coffee selection button image, and let's pass the argument coffee index, which is the property defined on the top of this file. Okay, save. And let's try to run it. All right, no change on the splash screen, so let's start, and beautifully, we have our application filled with the proper icons. And if you were going to enter the properties screen, there is also a small icon of our selected coffee. Let's verify that for Cafe Mocha, the image is changing also there, but still the back button is ugly. So let's try to fix that. Okay, and there is a back button QML for that. Let's enter that one. Okay, so we would like to have an image without the color and the size. Save it. All right. The text is also not needed no longer. And let's right now add the source, which will be another binding expression. Let's reference the mouse once again. Pressed. If it's pressed, then let's select one image, and if not, let's select another one. Back down.png and QRC button back normal PNG if it's not pressed. All right. Well, it should be it. Let's verify. Let's click start. Let's pick restart this time, and we have beautiful back button. And if I will press it, it changes the color. And in fact, it changes the whole asset, but those have different colors, and one is more white. And that seems to work. Let's verify that on our device. So let's change the kit to the board and to work in release. Let's start. And I will switch the camera. Maybe I will be quick enough. Okay. So still we have the old version and build process is ongoing. Okay, build has passed, and right now we are waiting for application to be flashed on the device. It will take still additional bit of time as we added more assets. It's also one cool thing that if you are not using some assets that are added inside the CMake list.txt, that during the compilation process, the optimizations and the LTO will strip out those not needed, and you won't have a bigger binary by this. And right now you can see the same splash screen and our images, which are displayed on a device. Now my camera is not good enough to show you the colors properly, but well, the images are clearly visible, and the back button is also there. Well, if I'm pressing it and swiping my button next to it, you can see that it's right now flashing with lighter color. And if I will release the finger, the asset is changed as well on the device. So without any changes to the application code, we are able to test our app on device and on the host machine. Let's get back to the screen sharing. Well, okay, so this is mostly about it. If it goes about adding the properties, the images and using them in your app. In the next live coding sessions, we will cover some kind of a properties and some manipulating of those assets, and we will try to add more of them as well. But right now, let's get back to presentation, and this is mostly it for today. So this is a good moment to ask some questions that are related to the whole day, to get some feedback, or even you can write directly to me on my email to